Okay guys, so now let's try question 6.1, which says show that g of x is equals to x plus 1. So now the first thing that we need to realize is that they are referring to a graph which is a straight line, and it's referred to as the graph of g. So now, since we know that it's a straight line, we're only interested in two things, which is a point where our straight line cuts the y-axis, and the second thing that we're interested in, the gradient of the graph. So because in this case we're given that point, which is where our graph of g cuts the y-axis, we can therefore use these coordinates and these coordinates to calculate the gradient of the graph. And from there, that's when we can, as the question instructs, that's how we can show that the graph of g is equals to x plus 1. So what I did here is to indicate that points along the graph of g, it's this point which is C, where 4 is our x and 5 is our y. And we also have a point where our straight line, the graph of g, cuts the y-axis. So I've also made a note here to say our y-intercept of the graph of g is equals to 1. So we already know that from our straight line equation, which is y is equals to mx plus c. So we already know that our c is equals to 1, because c refers to a point where a straight line cuts the y-axis. So at a point where our c is equals to 4 as x and 5 as y, we can use this coordinate in order to calculate the gradient of our graph of g. So what we do, we use this point to substitute into our equation of the straight line and calculate the value of m, which refers to the gradient of the straight line. So our y is equals to 5. You equate it to m, which is the value that you're calculating, into your x value, which is 4, plus 1, which is your c. So you calculate all of this in order to solve for m, which in the end is equals to 1.